Hello class. Today I'm going to give a little introduction about the simulation software that I've shared. So the simulation software was for to simulate the 8051 programs that we have done in the class. So after you install the program, you open the program. So it's a very light software, and then this is your workspace where you can type in uh, the program that you would like to execute. So I've already saved a program in one of the folders. So I'm going to load that program. So just one program I have loaded. This is the program that we have discussed in the class before. That is to find the sum of the three numbers 79H, F5H, and E2H, and to store the sum in two registers, R0 and R5, R0 for the lower byte and R5 for the higher byte. So in the program we start from the first line of code, which is the origin. We are going to store the program at the raw memory location 000. Then we are going to move a into accumulator, the first value, which is 79H. Then we are going to add uh, it's not case sensitive, but we're going to add the next number, which is the F5H. Here I've included 0 because if you're uh, immediately after the hash symbol, if a letter is appearing for hexadecimal value, you have to use the word number 0. So 0 F5H, and then jump on no carry. If there's no carry, then you jump to label 1. That means when you add these two numbers, if there's a carry, then you go to the next line of code, that is increment R5. Otherwise you go to without increment. If there's no carry, without incrementing R5, you're going to level 1. Okay, then the next line of code is add. Again, since the sum is stored in the accumulator, you're going to add E2H to the accumulator. So this is the second addition. Then jump on no carry to over. So if there's no carry between um, carry out of the 7th bit, which we have discussed in one of the previous classes, so you jump to the address which is pointed by the label over. Okay, but if there's another carry, if there's a second carry, then you increment R5. Okay, so once you increment R5, then move the contents of accumulator to R0. So the lower byte, whatever remains in the accumulator, is going to be stored in R0, and R5 is going to store the upper higher byte. Okay, so once you write this program, you save it. I've already saved. You can save it in any of the folders, any folder that you with the file extension .asm. Okay, after you save the program, you just check the system clock is at 12 megahertz. So this is the 11.095 megahertz that we have. It's close to that, and the frequency you can set it to 1000. So you can run this simulation software now. So you run the program counters. You can see the program counter here. Now you can pause it. Okay, so once you pause, okay, I forgot to show you the previous state of the two registers. So this program is going to modify the contents of R0 and R5. So R0, you're going to have the value 50, which represents 50. This is in hexadecimal value. Okay, so R5, R0 is going to have the lower byte 50, and R5 is going to have the upper byte. If you add these three numbers, 79H, F5H, and E2H, you will have 250H as the result. So the upper byte, like I said, is stored in R5. The lower byte is stored in R0. And the contents of accumulator, you see, because we have moved the contents of accumulator, but we have not cleared the contents of accumulator. So accumulator is still having the value 50. And regarding the PSW flag, program status word, this is the PSW flag. So you verify with the contents of PSW with the operation that we have done. Okay, so I have explained how PSW is affected. The program status word flag is affected by addition problems. Okay, so with this, thank you.